Hello, everyone. I wanted to make a quick video for you to help you graph rational functions in ALEKS. So we did some of these in class, and I made another video to help you figure out how to graph these things by hand. I also wanted to spend a little bit of time to show you a couple of different problem types in ALEKS because the way the grapher works on each one is a little bit different. So I'm first going to start with this topic, which is the graphing rational functions with holes topic. So it wants us to graph the rational function h of x equals negative 3x squared plus 12x all over x squared minus 5x plus 4. Now, the way that this graphing system works for this specific topic is that you'll use this hollow dot to graph your holes. This pencil will help you plot points. You have an eraser. You won't really use this drawing lines. You won't have to worry about that. And you won't have to worry about this one, which is graphing a rational function with vertical and slant asymptotes. We're not going to deal with slants. So this is the one that you'll use to kind of graph your function. Now, the frustrating thing about this is that this button is going to want to graph everything all at once. It wants to graph your asymptotes and your functions all at the same time. So you need to have a pretty good idea of where everything's at before you hit that button. So I want you to do some side work here so that we know what this is going to look like before we start. Okay, so let's do our side work here. I went ahead and copied my function over. So h of x equals negative 3x squared plus 12x all over x squared minus 5x plus 4. This is the problem that we started with. So to graph these, we're going to have to find our holes and vertical asymptotes first. And so we need to factor this to do that. So we'll take out our greatest common factor here, which is negative 3x on top. When I factor that out, I'm going to get x minus 4 up here. And then to factor the bottom, this is a 1, so I know I can just put my two numbers in parentheses with x's, and I'm looking for two numbers that are going to multiply to my c value of 4 and add to my b value here of negative 5. The two numbers that are going to multiply to positive 4 and add to negative 5 are negative 4 and negative 1. So I can pop those into the parentheses with my x's, and I'm factored. Okay, I have a common factor on top and bottom, so this guy's going to create a hole at x equals 4, which is the x value that makes that factor 0. So that's going to create my hole. I can cancel. Once I make a note where my hole is, I can cancel and simplify. And so I'm going to have negative 3x over x minus 1. And so now to find the y value of my hole, I can take x equals 4 and plug it into this simplified version. So y is going to be negative 3 times 4 over 4 minus 1, which is negative 12 on top, 3 on the bottom. Negative 12 divided by 3 is negative 4. So that means overall I have a hole at the ordered pair 4, negative 4. Okay, I can also find my vertical asymptotes now. Vertical asymptotes come from the factors that don't cancel on the bottom. So that x minus 1 that's left on the bottom will create a vertical asymptote at x equals 1. And that's the only factor we have down there. So that's our only vertical asymptote. Our horizontal asymptote is going to come from our end behavior fraction. So we'll create our end behavior fraction by taking the leading term on the top, which is negative 3x squared, over our leading term on the bottom, which is 1x squared. When we simplify this, our end behavior fraction simplifies to negative 3. As x goes to infinity, negative 3 stays negative 3. And so what that means is that we have a horizontal asymptote at y equals negative 3. All right, so that's our horizontal asymptote. Last thing I want to find is our x-intercepts. The x-intercepts come from any factors on top that don't cancel, so that negative 3x up here that we're left with, if we set that equal to 0 and solve for x, that tells us where our x-intercept is. So our x-intercept is at x equals 0, which is the ordered pair 0, 0. When x is 0, so is y. So that's our x-intercept. Okay. Now, really, these are all we need because to do this in ALEKS, the other type of graphing, you need 2 points on either side of your asymptotes. This one, you really only need 1. So the fact that we have a hole and an x-intercept will probably do this for us, but we'll kind of plot this in ALEKS and see. So I'm just going to make a note of these things real quick so that I can hop into ALEKS and I'll have these all right next to me. Okay. Okay, so we're going to start with plotting our hole and our x-intercept. So our hole, we'll use this hollow dot button. You'll move your hole to the ordered pair where it is. Our hole is at 4, -4, so right here. And I'll hit that to put that in. And then I'm also going to make a note of where my x-intercept is, which is the point 0, 0, and I will mark that. Okay, so once we have those plotted, this button is how we'll graph our function, and it wants us to graph everything all at once. So when you hit this button, it's going to put all kinds of stuff on here. The first thing it wants you to do is place your vertical asymptote. So you can see I can move it around here. Our vertical asymptote is at x equals 1, so I'm just going to put that right here. The next thing is our horizontal asymptote. Our horizontal asymptote was y equals -3, so I'll move that down there. And then it wants you to place your pieces. So this piece, you can really put it wherever you want. I'll put it over here through my x-intercept there. And the second piece you can pull around and I'll put that through my hole down here. So you can kind of see you do need a point on either side of your asymptotes to be able to plot these guys. So make sure that you have an ordered pair on either side of your asymptotes to use to place those function pieces. Once you have them placed, then you can hit the check button and we nailed it. Biggest thing here is that make sure you don't hit the check button before you put your hole in. I start with the hole so that I don't miss it. But if you plot your function first, just make sure to come back and put your hole in if you didn't do that at the beginning. Okay, so that's what the graphing tools look like for this graphing rational functions with holes. The other graphing topic looks like this. So graphing a rational function of linear over linear looks like this. This time, it's going to want you to plot your asymptotes separately. So you'll graph your horizontal asymptotes with this button. You'll graph your vertical asymptotes with this button. And then you will need to plot 2 points on either side of your graph. So you'll use this pencil button to plot your points, or you can use this button right here. I kind of mentioned this in class where if you have an ordered pair that's not super pretty, like if you have one that's at like 3 and then 7/4, 7/4 isn't a nice even number. It's hard to put that on a graph. You can type in your 3 and then 7/4 in here. So for instance, if I plot 3 and then let's say my y was 7/4, if I hit plot point, notice it just put that point on my graph for me at 3 7/4. That plot a point button will help you put a point in that's not super pretty if it's not like a nice ordered pair. And so once you have all of your asymptotes and your points in, then you will hit this graph a function button and then it'll fill everything in for you. So let's try this one. So our function is 2x plus 3 over x plus 2. So I don't have this one in already. So f of x was 2x plus 3 over, I believe, x plus 3, but I want to make sure x plus 2. Okay. 2x plus 3 over x plus 2. Okay, here's our function, and we want to graph it. So first thing you're going to do is holes and vertical asymptotes. Everything's factored here, so we can go ahead and see, does anything cancel? We don't have any canceling, so this thing doesn't have any holes at all. Vertical asymptotes are going to come from the factors on the bottom that don't cancel. So wherever x plus 2 equals 0, that's at the x value of -2, that's going to create a vertical asymptote. Horizontal asymptotes come from our end behavior fraction, which is leading term on the top, 2x, over leading term on the bottom, which is x. This simplifies to 2. As x goes to infinity, 2 stays 2. So that means y equals 2 is my horizontal asymptote. And x-intercepts, I will go ahead and look at that. So our x-intercepts are wherever the top, that 2x plus 3 is equal to 0. So when I solve for x, I get x equals -3/2. So that means our x-intercept is at the ordered pair -3/2, 0. That's my x-intercept. Okay, so with this function, with this graphing tool, we can kind of do things piece by piece. It's a little more forgiving. So let's start with our asymptotes here. X equals -2 and y equals 2. And we'll go ahead and plot those on our graph. So I can't seem to get the right one. There we go. All right, so we'll put our asymptotes in. So we have a vertical asymptote at x equals, oh, I don't know why it's doing that. At x equals, oh, -2, my bad. -2. And so I will hit that to graph it. Okay. And now I'll put in my horizontal asymptote. My horizontal asymptote happens at y equals 2. And I'll put that in. I don't know why this is having such a hard time. Okay, hopefully that stuck. And it did not. Y equals 2. I don't know why this is not having a very hard time staying still. I don't know why it's doing this. Sorry, guys. I don't know why this doesn't want to. There we go. Hopefully that should be there now. Okay, great. So our asymptotes are in, and now we can put in our x-intercept. Now this isn't a very pretty point, so I'm going to go ahead and use the plot a point feature. So I'm going to type in -3/2 and 0, and I'm going to tell ALEKS to plot my point. Again, ALEKS wants 2 points on each side of the graph, which means I'm going to need some extra points here. I'm going to need 2 points on the left side of my vertical asymptote and an extra one on the right side. So I'm going to plug in x equals -3 and -4. So if x equals -3, then to find my y value, I'm going to plug -3 in for x. So I'm going to get 2 times -3 plus 3 all over -3 plus 2. When I do that, y is going to be -6 plus 3, -3 on top, over -3 plus 2 is -1 down here. So that means y equals 3. So I have a point at -3, 3 on my graph, and I'm also going to plug in -4. When I do that, I get y equals 2 times -4 plus 3 all over -4 plus 2. Okay, so arithmetic. 2 times -4 is -8, plus 3 is -5, all over -4 plus 2 is -2, which gives me a positive 5/2. Again, that's not a super pretty point, but that's okay. We can use the grapher, so it's not a big deal. So these will be my 2 points on the left side of my vertical asymptote. So let's go ahead and plot those on my ALEKS graph. So we will plot, and I'm having a heck of a time getting ALEKS to work with me. So I'm just going to plot everything in here because, so we have 3, oh, sorry, we have -3 over here. -3 and 3 here. That's my first point. And then we also have -4 and 5/2. That's my other point. Okay. And we also need an extra point on the right side of my vertical asymptote because we need 2 points on either side. So I'm going to plug in x equals 0 to my function. All right, guys, I'm running out of space here. So let's just say x equals 0. Then y is going to be 2 times 0 plus 3 over 0 plus 2, which means y is going to be 3/2. So I also have the ordered pair 0, 3/2. So I will plot that one as well. 0, 3/2, and I'll tell ALEKS to plot that point for me as well. Okay, so I've got, and that didn't plot. Okay. Let's try it again. 0, 3/2. Okay. Perfect. So now we have all of our plots pointed. And so now that we have our asymptotes in and 2 points on either side, now we can hit this graph function button. It fills everything in for you, and you can hit the check button to receive credit for that. So those are the 2 graphers on ALEKS. Again, the graphing, the one with holes, you're going to want to do some work by hand so you have everything ready to go before you start graphing that, because it wants everything done all at once. But this graphing a rational function with linear over linear, you can do your asymptotes first, then make sure you plot 2 points on either side, and then just hit the graph a function button. So I hope that helps you navigate ALEKS and can help you save some headaches. Enjoy graphing rational functions in ALEKS, and I will see you next time.